and today we focus on food. My name is Sally Frost. I'm the Public Relations Manager in the College of Agriculture, Engineering and Science at UKZN, and I am your technical host for this afternoon. We are online because of COVID. Just some house rules for those of you who weren't with us last time. This is a Zoom meeting versus a webinar. We have a full house today, so please mute yourselves so that we do not have any background noise. On the bottom left of your screen, you will see there's a mute button and a video button. Keep the mute button on. If you want to save data, turn off your videos. On the top right, you can toggle between speaker view and gallery view. I would suggest speaker view is the best for the presentation. My colleague Christine Kuno is co-host this afternoon in case I have a power outage, but hopefully that won't be the case. We are being recorded, so after this session, we will send out the recording to everyone on the RSVP list, which you are welcome to share. And most importantly, in the bottom of your screen in the middle is the chat facility. Whilst you listen to the presentations, please post questions. I will go through them and then pose them to the speakers after they have spoken. And that's it for me. And now I will hand over to Prof Albert Modi, our DVC, who is the host for this afternoon. Albert, over to you.
Thank you very much, Sally, and welcome, colleagues. It's amazing, Sally, how much effort you need, very little effort you need to make people from 5 countries, when I counted, and almost half of the universities in South Africa, and many, many, many institutions and organizations to join our Fountainhill Estate seminars. So I would like to welcome everybody who has made time and effort to join us. Special thanks to the Fountainhill Estate Board, which allowed us to collaborate as different organizations, Fountainhill Estate, University of KwaZulu-Natal, INR and SANBI, to work together on this project, which is really, really successful as far as I'm concerned. As you can see, and I'm sure you spent your time before deciding to join us, we have different themes. Our theme for today, which is the second day of the seminar series, is food. Of course, the presenters are 2 people, not myself, so I'm not going to spend a lot of time talking to you because I'm not here to present. And those are Tafadzwa and Tilahun. I'm going to introduce them before they speak. But the question that I'm sure the world is asking is whether or not our food system is sustainable. And I'm hoping that that's going to be the focus of our debate from the agroecosystem perspective, as well as agriculture perspective. The first person who is going to be talking to us is Tafadzwa, Professor Mabhaudhi. He is an associate professor in the University of KwaZulu-Natal Center for Food and Transformation Systems, where he's a co-director. He's got many years of experience in the field of agriculture, but in recent years, he's actually been working very closely with organizations that also look to answer some questions of the policy and economy. He is very much used to collaborating with international organizations. And I'm going to hand over to you, Tafadzwa. I hope your presentation is ready to speak to us.
Afternoon, and thank you, Prof. I will go ahead and share my presentation. Yeah, there it goes. So I'll be speaking this afternoon on linking water, energy, food, and biodiversity for sustainable food production and livelihoods. And this presentation is basically a presentation from the Green Team. So the center, its staff members, the postgrads and everyone in it are generally referred to as the Green Team. So this is a collective presentation, if I may say so. So just to give some background on what we call the water energy food nexus, the water energy food nexus, or WEF nexus in short, is basically a holistic analytical approach. It's a systems approach to the governance and management of water, energy, and food resources, which takes into consideration the fact that the three sectors are interlinked and that issues in one sector can be transferred to the other. That is, there are trade-offs and synergies among the three sectors. And these are intricate and need to be carefully managed for sustainability. And this is particularly important in the context of a country such as ours, where there is increasing demand for resources, water, energy, and food. And those resources are currently stressed, and climate change is telling us that water is going to become more scarce. We know population is going to increase. So there's increasing pressure on these resources, which are finite, and we need to manage them more sustainably. And that is why it is very relevant to us from a sustainable natural resource management perspective, and also from a socio-ecological systems perspective, and for human well-being. So the core of the WEF nexus is really about improving human well-being and health through the better management of these three resources. And as a tool, we are looking at issues of environmental rights, dignity, equity, and social cohesion in terms of how do we manage the three resources to bring about, dignity to people in terms of water, energy, and food securities, to unlock their environmental rights in terms of how do they sustainably utilize their biodiversity so that they can live in dignity, and for equity, as well as to build social cohesion in terms of how communities are sustainable. And later on, I'll talk about where and how biodiversity can fit into this from an agrobiodiversity perspective. So just to give an overview of what we've been doing on the water energy food nexus from our group, we have mainly looked at it from the perspective of adaptation and ecosystem services. And we are looking at governance, economic efficiency, social equity, and environmental sustainability. And our aim is to apply the WEF nexus approach to achieve poverty reduction, job creation, simultaneous water, energy, and food securities, and to build resilience to climate change. That is the aim that we are looking at. And we are also looking at the sustainability aspect in terms of how do we then quantify the progress that we are making from a water, energy, and food perspectives. And also importantly, how do we translate the knowledge that is being generated from a research arena to be better able to inform policies and institutional arrangements so that these things are achievable. So there's a great need to work with people in government so that a lot of the knowledge that we generate from the science perspective can be translated and implemented. That is how we end up informing sustainable human outcomes. So this is just looking at South Africa's food system. We've got a dichotomous food system, which means that we've got basically two systems. We've got a formal and an informal system. Although in practice they integrate and work together, but they're generally two systems that are accessed differently. And you've got more of the commercial and large scale on the formal side, and you've got most of the small scale farmers on the small side. And then we've got issues of national and local policy or mismatch perspective, where South Africa nationally is food secure, but we still have an increasing number of people that face hunger and food insecurity. So we've got increasing household food insecurity. We still have a lot of people who do not have access to electricity, people without access to water, and people without access to improved sanitation facilities. So despite the advancement since 1994, there are still challenges that we believe that they can be sustainably managed through an integrated approach such as the water, energy, food nexus. And recently we've had an opportunity to see just how exposed and vulnerable our systems are as the pandemic tested the resilience of our systems, and they were found to be wanting and vulnerable. We had people who went into hunger immediately. We had people who could not access resources because the supply chains and value chains and distribution lines were disturbed during the lockdown. And it also highlighted the existing inequalities and legacies of apartheid era spatial planning laws in terms of how people in different areas were affected differently. So again, this all comes together when we are considering how do we manage water, energy, and food. We have seen just this morning as I was driving to work, I heard that the Competitions Commission is going to investigate large retail outlets, apparently for overcharging on ginger and garlic, because since the pandemic, everyone has been looking for ginger and garlic to boost their immunity. And so that's basically price volatility, that the market responded and increased prices for those particular items because they've been in demand. But beyond those two items mentioned, there are many other items that have suffered in terms of price volatility. And already the price of the food basket in South Africa was generally out of reach for most of the population, which is why there is increasing household food insecurity. And we've been advocating for a long time to strengthen local food systems from the perspective of people having access to own production and being able to meet most of their food requirements. So the pandemic and what happened put to test the national food system versus a local food system perspective, which would have been more resilient in this sort of instance. And then how does biodiversity help us? So I've just talked about local food systems and how they are more resilient and would have probably been better able to deal with the disturbances that we recently saw. So agrobiodiversity fits into these local food systems as a treasure trove that we have. So this is just illustrating how much food we have access to globally, between 300 to 500,000 species that we could actually be eating as humans and surviving. But sadly, it happens that only 3 out of those, almost 500,000 is what we utilize, for 60% of our calorific intake. So a huge loss in agrobiodiversity. So many crops, and yet people are hungry. We wonder, how did we get here? We've lost our diversification, and we've moved from systems that were sustainable into more unsustainable areas. And now we are always talking about moving back to sustainability. But this is part of the picture. How do we tap into that agrobiodiversity sustainably to achieve food and nutrition security? And what is important to understand is when we look at our agrobiodiversity, we are looking at accessible, affordable, and diverse foods. We are looking at locally adapted and resilient food species that do not press or place any additional pressure on the resources that are already strained. We are looking at healthier lifestyles. And so we're looking at improved nutrition, well-being, and dietary diversity. And our research has shown that these crops are well adapted to local and harsh environments. And our research has also shown that under climate change, these crops are going to perform better in some cases than the current major crops that are there. And our research has also shown that they are more nutrient dense, that is, they are healthier nutritionally than the current major crops, and that they are also suited to growing with low inputs, that is, they do not exert too much pressure on the environment. So we are looking at, from a holistic perspective, as biodiversity supporting food systems. And then we often talk about, people in rural areas and how they are hungry and how they've got land. But we also need to take into consideration that we now have a significant number of people living in the urban areas, and statistics indicate that by 2050, more than 60% of people will be actually in the urban areas. So we need to have urban areas that are also capable of producing food. And this is where issues of biodiversity become important. And this is where also issues of understanding the trade-offs and synergies in water, energy, and food and biodiversity become key. Because when we move into urban areas, unlike the rural areas, land becomes limiting. There is not much space for expansive agriculture. Land is limiting. Water is at a premium, because we're mostly going to be dealing with treated water. And also there's huge demand for energy from domestic and industrial purposes. So we have to be creative. So we've been talking about, utilizing urban spaces for foraging, where we plant edible plants and fruit trees in open spaces so that people can be able to forage and obtain food from these spaces. So it's basically getting the most out of the available land that is available in these urban spaces. And this is where also technology starts to kick in within these confined and land limited areas, which I think Prof Tilahun will come in and speak to in more detail, the technology side in support of water, energy, and food nexus. So we've got agrovoltaic systems where we can link voltaic panels on the same pieces of land to mitigate the competition between energy and food. So this is ideal for urban areas where the competition between energy and food, as well as land availability, is critical. And in South Africa, we're talking a lot about moving to renewable energies and independent power producers. So this can also create pockets of small independent power producers within the peripheries of our urban areas. There's still the debate around biofuels. Whilst the policy currently is in favor of sorghum and soybean as the biofuel feedstock, but we also need to be considering other sources, especially second generation feedstock that we can use, which would be readily available and can easily be converted to energy, especially in rural and peri-urban areas. This is just, again, emphasizing on the range of technologies that we have at our disposal. So that is, a solar-powered farm vehicle. You can see the solar there. So you can have solar irrigation. You can introduce a lot of renewable energies into the agricultural space, thus mitigating the demand for energy. Just this morning, I was having an interview with a radio station in Mpumalanga, and we're talking about how energy is the primary constraint for irrigation expansion or agricultural expansion in Africa. So we've got to tap into these renewable energy sources to mitigate the demand on the energy grid. And also farmers could end up being independent power producers and being able to sell off excess energy that they generate to the grid. And we also need to think about innovative approaches. We've been working with some of our colleagues in the School of Engineering Sciences, thinking about hydroponics, things like vertical agriculture. We are working with our colleague also, Prof Christina Troyer, thinking about how we can link micro digesters into this system so that they can generate energy for the household from biomass, which could be, recovered from invasive alien plants in the rural areas and then used to generate energy. Things like rainwater harvesting that can be deployed also for irrigation at a small scale. And such irrigation can be solar powered. With Prof Tilahun, we just finished designing a pack house that will be installed in a rural area, which is a low-cost, energy-efficient pack house. Instead of using refrigeration, it uses evaporative cooling. It's able to recycle water. So it's basically got a low energy footprint, and it is greenhouse gas friendly. So that's basically, taking the link from the water energy food nexus. And then you can take these technologies and apply them now. Instead of producing the lettuce that we are seeing here in the cabbage, you can come in now and bring indigenous crops that we already know utilize less water and are resilient, and produce them and provide food more readily to people in both urban and rural areas. And they can also be considered as niche foods or superfoods, as some are calling them, which can be exported, creating additional sources of income for women and youth in rural areas. And so where we are now with our research, which is my last slide, is we have done a lot to understand the context in the last couple of years, the South African context in particular. We have done a lot to understand the barriers, what is stopping progress from happening to achieve, the vision that we want on improved livelihoods and ecosystem services. And we have mapped the activities that need to be done around developing tools, which we are doing, establishing quantitative relationships. As Prof was saying earlier on, that I work a lot with different sectors of the economy, stakeholder engagement. So we have mapped the activities that need to be done, and we are now at the stage of implementing a range of these activities together with our partners, some of whom are here today and some who are not. And this is just mapping what we expect in terms of outputs and the programmatic outcomes that we hope to achieve through this approach that we are taking. So we are now at a stage in our research, which is why our center is called Transformative Agricultural and Food Systems. It's basically to say we are now moving from theory to practice, from planning to doing. And we are hoping that through approaches such as the water energy food nexus, looking at things from the agriculture, environment, and health perspective, we can unlock a lot of wealth that exists on the African context within our agrobiodiversity, and use that to achieve sustainable human outcomes linked to job and wealth creation and sustainable natural resources management. So that is our vision, and that is how we are slowly working towards it. And I'll also use this opportunity to invite people on this platform to come and partner with us on this journey. I guarantee you it's exciting. We are doing a lot of exciting things, and we are looking for partners out there to work with in all sectors and from all walks of life. So don't worry, we welcome you. And just to thank our key sponsors who have allowed for most of this research to happen, the Water Research Commission, the Chefs Project, and the Umgeni Resilience Project. Thank you very much, colleagues.
Thank you, Tafadzwa. Thank you very much. I don't want to score brownie points here. It's amazing when your student from a master's degree to a PhD to training at postdoctoral level can now stand on his own and be visible nationally and internationally. That's my brownie points. I see there's a lot of questions, colleagues. My plan is that we have both presentations, and we open time for questions right at the end so that we can ask questions from both presenters. So let me now allow Tilahun, Professor Wagner, who joined us in our efforts to make a change in South Africa, particularly in KwaZulu-Natal, and influenced our view of the use of technology from the engineering perspective to improve food security in KwaZulu-Natal and in South Africa. So Attila, I'm handing over to you. Hello?
Yeah.
Am I
Can
still
you hear me?
audible? Okay, so sorry, I don't see my face.
Okay.
Go ahead, Tila.
Okay, Tila, yes, I'm here, Prof. Good afternoon, everybody, colleagues and friends. Thank you for Prof. Mode, the DVC, for providing me with the opportunity to share this presentation today. The content of this presentation is information that I have gathered from literature and from our own workshop. This presentation aims to create awareness of the current emerging technologies for food production and prospects for the agriculture sector in this fourth industrial revolution era. The topic of my presentation is sustainable engineering technologies for food production at present and in the future. So the outline of my presentation is a little bit extended, but we will be able to really cover during this time since we are creating awareness at this stage. Now, as an introduction, literature will show that 3 decades from now, in the 2050, the world population is expected to reach, as you see, 9.8 million, approximately almost 10 billion, sorry. On the other hand, the projected urbanization is predicted to reach about 68% in 2050. And the interesting aspect of this is that by 2050, the world is required to increase its production, food production mainly, by up to 20%. And it has been indicated that most of the increase in food production should really happen in our own continent, Africa, including our country here in South Africa. So there is really a huge task ahead of us. And considering the food producers in Africa, if we consider the proportions of farmers in the African continent, there are 75% smallholder farmers, as you see, 20% are small industrial, while only 5% of farmers are categorized under industrial or commercial farmers. This data shows that the majority of food producers are smallholder farmers who are still using traditional farming methods. And the question that we might ask ourselves is that, can emerging technology leapfrog what holds back the growing of food production and the processing in our continent? Emerging food production technologies are expected to be extensively implemented in the continent to cope with the existing demand for food. So we need to have a look at the existing forms of rural, I would also add, urban and the pre-urban agriculture. At the moment, there are different forms of agricultural activities in rural, urban, and around the cities. These forms of agricultural food production activities can be categorized as we all see into different types, but it actually extends from rural through to pre-urban and urban. And however, this effort that we really receiving from the governments, private and of course public organizations need a support in terms of the introduction of technologies that ensure sustainable food production and processing, handling in the supply chain. Now, the sustainability in the food supply chain, well, how can we ensure that sustainability in food production, food processing, and the associated food waste management? I think my colleague Tafadzwa had been discussing all these linked integrated food supply chain requirements. And the most popular view today is to develop and implement complex network of activities that include primary food production, as you see, processing, distribution, retailing or catering, and consumer handling. So generally, the literature that we have today shows that sustainable food supply chains aim at efficient food production and the whole mentioned unit operations, as you see in the supply chain. So now we need to implement an integrated agro-technological approach, very important to really secure success. And in this case, during the development and implementation of sustainable food production and processing technologies, it is important to apply knowledge from a multidisciplinary areas where scientists, engineers, the industry practitioners, and so on and so forth needs to come together, work toward this further developing, adopting these technologies. Now, the question that we might ask ourselves again is that as engineers and the scientists and implementers, what are the main considerations in engineering to control or to come up with controlled environment for food production and the processing? In this case, what I see is that to ensure the implementation of sustainable food production and the processing, technologies that enable to control environment should be developed or adopted. Okay, so we need to underline environment, engineered environment. It is not the duty of only one specializations engineers. It is the holistic the nutrient solutions, nutrient pH, light, and so on and so forth. So in this era, all the technologies that we wanted to develop is around controlling these technical parameters. So then sensors comes in and other IT technology comes in, and then we ensure that we produce quality product. With the current emerging engineered technologies and the data plant can sustainably be grown for food and for other purposes, fiber or raw materials for energy and so on. So now we will have a look at engineering technologies. I would rather call it engineered technologies or controlled environment technologies. I remember almost 20 years ago when I took farm-state structures. These technologies now we hear never mentioned in that books, and later I came to teach farm-state structure, which is very much different from what I am delivering to my students at this stage. So the technology has been progressed quite high. So one of the fast-growing emerging types of controlled environment for food production is indoor farming. So indoor farming is, as you see from this picture, where controlled environments are required. And what do we control? Because we have engineered environment engineering here, we have engineering science here, we have environment there, we have living things there. Living things can give us better result if we control the environment around it. So there, the engineering input comes, science input comes in. Okay, so different types of controlled environments and food for food productions are today available in the market, and greenhouse is the most popular one. I think all of us know, but the greenhouse we know today is not the same as the greenhouse we know 20 years ago. Today, with advances in technology in this field, with smart technologies came into play, the greenhouse technologies are smarter, and we can see it from the remote and really control and so on and so forth. So, but the important thing here, as my colleague Tafadzwa has mentioned, the most important thing is the input of production. One of the input of production is energy. So 20 years ago, today, I also remember renewable energy, teaching renewable energy is a theory. It is a theory, but today, really the use of renewable energy in agriculture is realized. And we need to pick this and advance the integration of renewable energy in running fans, pumps, and as we circulate water in hydroponic, aquaponic, or in greenhouses, and so on and so forth. So it is really very important. Now, the other fast-growing type of technology, as has been mentioned in the previous presentation, is vertical farming. It is becoming very popular, which is used vertical spaces associated with structure. A vertical farming works well for small space and highly high density spaces, and it is suitable for vegetables production at different scale, rural, pre-urban, for urban, and the control technical implementation parameters remains as I have discussed in the case of greenhouse. But this is really something we need to pick in South Africa. There are startups here and there, but I believe this is the technology that flies throughout Africa. Maybe the Southern Africa will drive this process given the existing technical knowledge. Okay, then the other aspect is building integrated agriculture, where we integrate agriculture into the building environment. And this is again an innovative approach to food production. Why should we integrate building agriculture required? The other fast technique where the principles underlying built environment in agriculture is implemented to solve the food security, especially in pre-urban and urban setting. So this is one of the technology really we need to harness in the future across the African continent as well. Now, the technology provides solutions to practice hydroponics, greenhouse farming systems in mixed-use building in cities and towns. It has proven advantage to effect principles, and one of the aims of the combined built environment agriculture, as I've discussed, some of the characteristics that approaches are used for hydroponic within circulating water or energy regeneration, underlying energy regeneration. This is really something the world is still missing. A huge amount of energy is being generated in a building, whether from living animals, human, plants, and machineries, but simply dissipated to the surrounding. In this building integrated agriculture, this energy can be repurposed, recirculated, and then used to run machineries in the system, and so on and so forth. But it is very interesting. Now, let's go to a specific controlled environment food growing methods. As you can see a tremendous amount of fruits beared here, and it is clearly indicates that these emerging technologies are the future for us. There are different types of controlled environment for growing methods, and the first one you might really heard many times is hydroponics. Hydroponics had been already applied in many places in Asia, Europe, and America. But Africa this is one of the future for Africa and South Africa. And in Southern Africa, again, with the technical capacity and the technical manpower availability, the possibility of coming up with workshops and to manufacture these technologies, further develop, adopt to the environments, and then distribute throughout Africa using partners will be one of the area I can see is the future. The other aspect or methods is aeroponic. Look, in hydroponic, we grow plants soilless in water, but of course we can use medium without soil. But when it comes to hydroponics, food is grown without soil and using little water. Hydroponic, relatively more water, but still highly efficient compared to conventional agriculture water requirement. Then the roots of the plant are suspended in this case in air and sprayed with a nutrient and water solution in a controlled environment to ensure the nutrient mist is captured. The plant scientists are really responsible to quantify the nutrient solutions required for each plant. The engineers comes in and develop sprayers, the nozzles, the pumps, and so on and so forth. And the computer scientists will come in and work on the control system. So we need to really move into that direction and then integrate our efforts. Aeroponic is one of, again, the future because it uses 90% less water compared to even hydroponic system. Now, the other method is aquaponic. I must say South Africa is doing very well with aquaponics. I think I would like to really thank, when I look at literature and the see facts and the figures, aquaponics for some time had been actually developing in South Africa, and the economy is also somewhat benefiting from it. And this is another important aspect. So aquaponic is practically combining hydroponic with aquaculture. Aquaculture is where we grow marine animals like fish, different fish types, and on the other hand, that byproducts from the fish is used, transported by bacteria to the plant root zone, and the plant uses that. No need for chemical fertilizers. So isn't this technology smart? And when this is combined with smart technologies, computer control technologies, then we can really make use of it. As we can see, in 2011, aquaponic also contributed around 379 million rands, and the production, the freshwater aquaculture production was also about 2,921 tons for 2011. So this is these factors have been improved by now, but still quite a long way to go. Rural, pre-urban, and in urban settings, this technology will definitely fly, colleagues. And now this is the figures that we have. And now, so once we are through with this technology, the next step I would have just highlight is that the use of sensors and robotics in food production. New emerging food production technologies that we were mentioning in these both presentations are intelligent. They are intelligent factories because they run with the control systems and development and integration of the use of sensors and robotics emerging food production ensures really the sustainability of what we are really presenting. So sustainability depends on when we integrate these technologies, existing technologies. Remember, there was technologies during Babylonian time, but we need to integrate it with the recent technology. Robotics for large-scale commercial production and sensors at any level. Today's sensors are becoming cheaper with digital technology advances, and it can be integrated to small technologies in the farm, hydroponic, aquaponic, aeroponic, and so on, through to urban settings. Now, the advantages of the sustainable emerging food production is obviously already proven to be that acceptable level of resources efficiency, specifically water use, energy efficiency, because partly renewable energy can be used and integrated to run systems. Robotics can be used in large scale production, and it enables year-round production. Colleagues underline this, enables a year-round production. Under any harsh environmental conditions, we don't depend on environmental factors, except in controlling the microenvironment inside the engineered system. Promotes production of best quality, uniform quality of produce, cabbages, strawberries, and so on and so forth. So I am coming to my final slide, and I'll just make some recommendations, and we see ourselves where we have to go as a scientist, as industrial, technical industrial workshop owners, as agriculturalists, and as a youth looking for career in the future, as entrepreneurs, and so on and so forth. So increasing investment in research and development of new emerging food production technology is really important. Increased opportunities in adoption of the technologies, opportunity for collaboration between expertise in different interdisciplinary fields of plant sciences, engineering, computer sciences, marketing, social sciences, psychologists, because these technologies will not fly unless and otherwise psychologists come in and really talk to and know what the people really want us. And the training and employment opportunities for use in the areas of this emerging food production technology, whether it is in rural, urban, or pre-urban, at different scales can be manageable. And business opportunities in urban, yes, this is what I am really interested in very much, especially as we focus on a big population of youth in South Africa and elsewhere in African continent, and opportunities for industrial farmers, and the availability of seasonal food and medical plants in markets are always available with this technology. Thank you very much, Prof.
Thank you, Tila. Thank you very much. You can stop sharing your screen for now. Can you stop sharing your presentation? Great. Thank you very much. Colleagues, you know, initially I was supposed to be a speaker, and then I said, you know what, I'm too important to be a speaker. And there are people who are too important to be speakers, and therefore they must come and speak. I'm very proud that the work that we do in our research center has gotten an opportunity to be shared with the world. I'm very proud of the two colleagues who were able to combine the efforts that we're making, trying to change agriculture from the perspective of teaching it, doing research, and particularly influence the majority of people who think that agriculture is just getting dirty. Farming is an incredibly complex science. It doesn't matter which farmer you talk to. So that's the message. And also, one of the things that we are trying to do is to change South Africa. In our center, we have a dream to establish KwaZulu-Natal Small-Scale Agriculture Institute, where there's going to be a board where Mamkhize, Magubane, Mrs. Jones, and all of them get together and they make food produced. We need the support of the government. There was somebody who was asking about our relationship with the industry. We are struggling. We are really calling for the colleagues who are coming from government to look up to universities. Come to us at UKZN. It's not going to cost you a lot of money. All you need is to identify opportunities for us, and let's work together with the budget that you have. We've got a large number of young people who are qualified and they are not working, fortunately not in engineering. So let's put our hands together and make sure that this happens. So it's time for you now to answer questions, Tila and Tafadzwa. You know, I've been looking at comments that are coming as questions. To me, there are three big things. People hear about climate change all the time. You know, we live, according to your presentations, between the soil environment and the aerial environment, and there's a lot in between. Are we realistic when you talk about climate change? And what do we really mean by climate change? Another question was indigenous crops. What do you mean by indigenous crops? Which ones have got great opportunities? Give me a few examples of indigenous crops. And the third thing is the concept of emerging technologies. Does that not basically give the impression that emerging technologies are simple, they are easy, and they are cheap? Tell us, how are we going to move forward with these engineered systems of agriculture without the fear of them being too expensive for the target population, that is the poor people of South Africa and the world? So I'm opening it up for question. I don't know, Sally, whether I should hand over to you, but I can take questions. Colleagues, Sally, can you guide us in terms of how people raise their questions?
Albert, we're almost out of time, so I think we should allow Tafadzwa and Tilahun to answer the questions you've just posed, okay, and then wrap it up. So maybe Tafadzwa could go first, and then Tilahun.
Thank you, Sally. Very interesting questions. So climate change is real, it is ongoing. Basically, from a South African perspective, there are two things of concern, which is the rise in temperature and the impact that climate change will have on water. This will be varied across the country, so it won't be a one size fits all. But the trend in temperature is consistent, that temperatures will increase. Water in certain areas is going to become drier. There will be increasing extremes in terms of things like flash floods and droughts. So it will just make the process of management and planning a bit more difficult. In certain instances, it's going to mean that certain crops, the suitability areas are going to shift. For example, in the Western Cape, things like apples require what are called chilling units for apples to produce. So they must receive a certain amount of cold days. So if it gets warm, they are not going to accumulate those chilling units. So they might not break dormancy and there'll be no apples. In some instances, certain crops are produced in certain areas because there are no pests for those crops in those areas, mainly because of the temperatures that are not conducive for those pests. But if it becomes warmer, those pests will move into those areas. and the cost of pest control added to the original costs that are there may make it unviable to continue with production of those crops in those areas. So the implications are broad. Then to answer the
so now tell us, Tafadzwa, I'm watching the time. Now tell us about the meaning of an indigenous crop and underutilized orphan crop. Explain to us.
So we refer to them broadly as underutilized indigenous and traditional crops. And that includes crops that are native to South Africa, those that originated from South Africa, and those crops that have been domesticated at least over 100 years in South Africa. So there are crops whose scientific center of diversity might be outside of South Africa, but we may refer to them generally as indigenized or traditional in the context that they have been domesticated over hundreds of years, and we now have what we call local land races of those crops available in South Africa. Examples are things like taro amadumbe. It does not originate in South Africa, but we've domesticated it over hundreds of years, so it is now technically an indigenous crop. Things like sweet potato, maize land races, the colorful maize that we use, Bambara groundnut Izinglubu, cowpea imbuba, and several imfino that we utilize in the rural areas. A lot of those have their centers of diversity outside South Africa, but they have been domesticated and utilized by Abantu Kaya for more than 100 years. So
okay, thanks, Tafadzwa. Let's ask Tila now to explain to us why does he think that we need new technologies? We were created to produce food from the soil, and now you're telling us that there must be alternatives, and engineers must design their systems in the urban areas so that we can harvest energy from the urban areas for production. Why is it important to use these technologies, and are they really a realistic way of moving forward? Tila, you've got 1 minute.
Okay, thank you, Prof. I think the questions raised were very important. And in terms of sustainability, now look, we talk about the arid zone agriculture, dry land farming. Research is going on. And when it comes to this emerging technology, it is all about controlling the environment, which means we cool down the temperature from harsh Saharan temperature to comfortable temperature to 20, 25 degrees centigrade. So there is no chemicals added there, but in fact, cooling down evaporatively, for instance, the temperature down to a comfortable zone, comfortable temperature for plants. So, and the fact that we don't wait for weather or season to come to produce food, it makes it very sustainable. It makes it very suitable to combat the issue of food insecurity and so on and so forth. In terms of
okay, yes. I'm looking at Sally. Sally is telling me that I have now seconds. Thanks a lot, colleagues. You answered a lot of questions during your presentations. Sally, is it time to wrap up?
Yes, it is, Albert.
Okay, colleagues, one more time. I don't know how many times I'm going to thank you, but one more time, thank you very much for joining us. And please take the message that we are doing this so that we can share knowledge with people. And we are also doing it in order to showcase how much organizations, institutions, and farms like Fountainhill Estate can influence the research and thinking of people out there. We are inviting you to come and work with us. Thank you very much, Sally, for doing so much work. We've got another another seminar. This is a series. Please make sure that you continue to join us. Sally.
Thanks very much, Albert, and thanks to everyone who attended. We will send out the recording of today so you can share it with your friends and colleagues. And we hope to see you again in 2 weeks' time. Thank you, everybody. Goodbye.
Thank you very much. Bye-bye.
Thank you. Thank you.
Thank you. Bye. Bye.
Bye.
Bye. Bye.